Good morning, everybody.
All the freshmen. Well, no. I think it is. I think they're like seniors.
I wonder who else is going to be
I don't know. You really gave it to someone else.
We have 2 handouts on the front table. If you'd like to grab those, please.
I'll get you one. Oh, I have one.
What? Are you? What are you? Just but I still gotta like run warm up and stuff tomorrow.
Yeah, I'm gonna switch it so that tomorrow they can show you then. Let's see.
Share on Facebook. Yeah, like I don't want to share on Facebook. I just want to person. So you find it. Plus, I'm plus the VA one, which I think you guys want. Oh, okay. Yeah, so I
think it's good. I got it for free, so that's kind of cheap.
It's really nice.
It does.
Like, there's one that I'm not even going to apply to.
I had one doctor literally the day that I moved to go just later.
Yeah, I just sent this one.
And that's okay. We're not yet started.
Guys.
Okay, so
Okay, we have 8:30. Why don't we get started? Good morning, Psych Stats.
Good morning.
Welcome to the end of week number 9. Who's ready for a weekend? Yeah, okay. It's been a long week. I can't believe when we come back we're going to be in double-digit weeks. But there it is. We're moving right along through the semester. And we've got our usual good news. That is, we're coming up not only on a quiz, but also on an exam. So can we give it up for the written exam? Yeah? All right. People are excited about the written exam. So what I'd like to do first is we'll start with that most distant target and then work our way back in time to the intervening targets. Okay, so let's go ahead and take a look at that. I've got that here. Ah, there it is. Okay. And this is one of your handouts. Okay, so hopefully everybody grabbed these handouts. And if you haven't, please make sure that you get there are 2 handouts on the front table. Please make sure that you grab them. So this one's going to be very similar to what you've done in the past, but just a little bit different. It'll be topically different, and the structure of your writing is just a tad different, but not very much so. I wonder if we can get a volunteer reader, please, from the top where it says, "This is your brain on multiple variables." Can I have a volunteer reader, please? Okay, thank you, Gabby.
This assignment is designed to improve your understanding of statistics, improve your writing skills, and refine your integrative complexity. Begin by reading the following 3 articles.
We don't have to read those details, but subsequently?
Subsequently, write about 1,500-word essay summarizing the 3 articles with a particular emphasis on the statistical analyses. Your essay must present the articles in the above-shown sequence, but do not number your responses. Instead, your essay should smoothly transition across the articles, each of which should be summarized in approximately 500 words.
And can we do the rubric? The rubric is just a tad different this time.
As always, your grade will be based on the quality of your writing style, grammar, clarity, succinctness, organization, and transitions. See additional styles issues listed on the back of this page. Additionally, your grade for this assignment will be based on your ability to integrate disparate ideas and demonstrate an understanding of statistics.
Okay, very good. So in the last couple of weeks, what we have been working on in this sequence was that set of statistical processes. We were looking at multiple regression, and then we went all the way down to t-tests, and we're now building our way back up to something very conceptually similar, both to t-tests and multiple regression, and that is factorial ANOVAs. So we're going to do each of those across these three, and we want to see how you're commenting on them and describing what the researchers were doing. We're hoping you can tell a relatively smooth story. I find that it's fairly easy for me to connect any two of these. Putting all three together is a little bit harder, so we'll see how you can look at those and tell a relatively smooth story in about 1,500 words. Okay? And you'll have the electronic copy, as always, uploaded into Blackboard, and I'll be able to provide feedback to you electronically. You'll also bring the paper copies, please. We'll be at that back table next Friday, and we'll do our writing workshop. Okay, and you can see what your classmates have done with these different statistical procedures across three moderately different papers, but they're all dealing with the idea of multiple variables on your brain. So a little something for those of you who might have an interest in the biological side of psychology. Okay? Any questions on that? Okay, so that's going to be next Friday, right? And to remind you that we also have a quiz that's coming up. Okay, and we've seen this a couple of times, but I wanted to do it one more time here today. So the context, all things here are low stakes, okay? And they're low stakes because we like to have more of a ramp than a staircase. We like to have these small steps up. The format will be very similar to what we had the last time. You'll have the 50 minutes for the session. Here is a list one more time. This is out on the S drive of the Excel skills that we've been using and will be using today and the next couple of days. Today you had a TED Ed, by the way, and we will not have a TED Ed for Wednesday. We will have a TED Ed for Monday. Okay, we're going to be talking about Dr. Brooks' article on Monday, but more on that in a moment. Just to finish this idea, here are some of the things we've been doing in SPSS. We've been doing ANOVAs and multiple regression. We'll spend some more time on that today as we begin to talk a little bit more about factorial designs and we get into this interesting issue of orthogonal trend analyses. Okay? So that's available to you out on the S drive. And just as a reminder, there's a TED Ed ready to go on Dr. Brooks' work. And this is an interesting paper because it's Dr. Brooks publishing with 3 of his students from a few years back. And he's talking about such things as extinction and spontaneous recovery. How many people remember those terms from Intro to Psych? Extinction and spontaneous recovery? Okay. So he's got some really nice models that I think will make for a good conversation. And that'll take us for the first half hour in Monday's session. And then I think we're on for Vanessa. Right? You've got that ready to go. Okay. And then the following week will be Gabby. Okay. And then we're off to our visiting speakers for the Monday sessions. Okay. So that's where we're going, big picture style. Okay. People okay with that? Yeah, all right. Okay. So why don't we remind ourselves of where we were relatively recently. And we were talking about some issues that pertain to factorial designs. And let's get a brief reminder, because it's still very early in the morning. Somebody remind us, what do we mean by a factorial design? Okay, thanks, Hannah.
There's more than one independent variable.
There's more than one independent variable, and for our purposes now, there's still one dependent variable. Okay, one dependent variable. What kind of scale, and this is, I think, in one of your questions, what kind of scales could we use for a factorial ANOVA on our dependent variable? You have 4 different varieties of scales. What kinds of scales would be appropriate? To remind ourselves what the scales were. We have a very rudimentary scale that we learned about. You know, let's do our scales. What's the most rudimentary variety of measurement scale? I'm sorry? Category, yes, categorical, okay. And then we can go up one notch, and we're up to what kind of a scale? Ordinal, which is also called a rank scale. Okay, then we can go up one notch, and that might be interval, and then finally all the way up to ratio, okay? And of course in SPSS they combine those last 2, and they call that whole thing very confusingly scale, okay? So we have to have some kind of, if you will, scale variable on our y-axis if we're going to be doing an ANOVA, either one way or factorial. Hannah was correct in mentioning that we have multiple independent variables. A little later on in the semester, we'll be talking about multiple dependent variables, and we call those multivariate analyses, which is fairly easy to confuse with a factorial design because we do have multiple predictors, but we still have only one criterion variable, one dependent variable in the world of factorial ANOVAs. So we've been doing this kind of a thing. We were doing factor A, factor B, and the A by B interactions. Okay, and we had all different kinds of combinations over here, where we were plotting a DV, an unnamed DV, just very generic, as a function of two different variables. Factor A is plotted here on the abscissa, and then we also have a parameterized variable. Okay? All right, so why don't we do just a couple of these, and I'll have you walk me through, and you tell me where to get these things going. So I think it's fairly easy when we have only one of these turned on, factor A, factor B, or the A by B interaction. But we can have all three of them turned on, or two of the three turned on. So why don't we try something like, I think we did this and factor B yesterday. Why don't we try factor A and the A by B interaction, and we'll leave factor B as non-significant, okay? So I'll let you think it through. You can also dial into your TED Ed for the other day. This was the TED Ed that was due yesterday, okay? Just to do a little bit of review, and we'll see how people are doing on this one. Okay? You might attempt to try to memorize all that. I hope you won't. I think really the best way to memorize something, so to speak, is to understand it. So if we can just think about what would have to be true for factor A in our graph so that it comes out to be statistically significant, and that can be advantageous. Okay. All right, somebody want to help us out with this? I think this one's a little bit tricky. Okay, thanks, Shelby.
So the first B1 can be at 1.
The first B1 can be at 1. Okay, so I'm going to... At 9, thank you.
B2 can be at 5.
And did you say this one too?
Yes.
Okay, perfect. Okay, let me connect those dots. And let me connect with Shelby. That was excellent. Okay, so let's see what Shelby has here. Let's take a look at A1. And A1 has a mean. You tell me, what does A1's mean? Can you yell it out? Okay, right, because it's halfway between 5 and 1. Are people okay with that? So I can put just a little dot there. Okay, and A2 has a mean of 7, okay? So looking at that, I think it's reasonably safe to conclude that she's maxed out on how clearly she's put that together. 3 is different from 7, and so we probably have a main effect of factor A, where specifically A2 is greater than A1 in this case. Who's following that? Okay? All right, so she's satisfied the first constraint, okay? Let's also take a look at what's going on with factor B. Okay, what is the mean for B2? Those are x's. What is the mean value for B2 numerically? 5. People okay with that? Okay. 5 and 5 averages out to 5. Okay, right. How about if we look at B1, which is shown in circles? What's that average? 5, okay. And that's, hopefully you can see that intuitively, or you could have done 9 plus 1 divided by 2 is 5. So I think it's really handy to have 0, 1, 5, and 9 here. Okay, it's a fairly straightforward scheme. And so now we have 5 and 5, so there's no effect for factor B. As we move from B1 to B2, we don't get a change in our dependent variable. We're at 5 in this particular case for each of those. So factor B, as per the requirements, is non-significant. Okay, so Shelby's 2 for 3 so far. And then are we all agreed that there's an interaction that goes on there? Is that working for us? Okay, I'm going to plant just a little bit of seed to help us understand orthogonal trend analyses in just a little bit of time. One of the tricks that we can use, of course, for looking for interactions is to look for some crossovers, okay? Whenever we have a departure from parallelism, we have evidence for an interaction. That's one of the take-home messages even from PSYC 200. Who remembers that ditty? That one, okay? All right. The other thing that we can do is something that was listed in the PowerPoints. We haven't spent a lot of time on it. It's about finding differences. And we might play a little differencing game like this. We can say, why don't we take B2 and subtract from it B1? So if I take 5, and I subtract 1, I come up with positive 4. People okay with that? Right? Let's take that positive 4 and put it into our back pocket. And now I'm going to take B2 and subtract B1. 5 minus 9 is negative 4. So I've got a positive 4, and I've got a negative 4. My first difference is positive 4. My next difference is negative 4. I have different differences. Can we all say that together? Different differences? One more time. Different differences, okay? It sounds like doublespeak, but we're really getting a difference here, hanging on to that one mentally, getting a difference here. And to the extent that the differences are different from each other, then we have evidence for an interaction. Visually, that will always be true when we have these crossover interactions, and it will be true to the extent that we have departures from parallelism in our graphs. But that's one of the ways of thinking about that. The reason why I say that is in a little while we're going to be talking about orthogonal trend analyses. And the orthogonal trends just in the regular data are not that hard to see. What's a little bit less intuitive is finding orthogonal trends in interactions. But if we can think about the orthogonal trends in our interactions as being plots of different scores, okay, and we have maybe identical differences, or maybe we have different differences. And maybe the different differences form a particular pattern. Maybe it's a linear pattern of different differences. Maybe it's a quadratic pattern of different differences. We'll see a couple of examples of that. But it's helpful to think about these interactions in two ways. Okay, here's the crossover, and we're getting different differences. Who's all right with all of that? Okay, very good. Why don't we try one more, because I think the group is getting onto this pretty well. I'll erase this. And why don't we try the hat trick? Okay. We'll let you think it through. Why don't we turn everything on? Okay. And now, how would this 2 by 2 graph, and it's 2 by 2 because we have 2 levels of this variable, 2 levels of this variable. We'd be running a two-way ANOVA on this because we have 2 independent variables. Okay. So you can dial into your TED-Ed if you like, and maybe somebody can walk me through on what this might look like. Okay, Melanie, thank you.
So I have factor B1
Okay.
at 1 both times.
At 1 both times.
And then I have B2 at 1 and 9.
Okay, let's go through all of that and see how we do. I'm going to connect this with a dotted line. Okay, and I'm going to connect that with a solid line. Okay, let's take a look at the main effect of factor A. Okay? So why don't you tell me, can we have somebody tell me, what are the respective means for the levels of factor A? A1 has a mean of 1, and A2 has a mean of 5, okay? And 5 is different from 1, so we probably have a significant effect there. Now, somebody might quibble. First, I think this is fine. That works really, really well. Somebody might quibble and say, oh, but you also have very different variances. but we're not going to do the variance question right here for this purpose. We can see here that we have a mean of 1 here and 5 there. We're going to have very little error bars here and much wider error bars here. Is that clear to people why we're going to have wider error bars here? Because we're going to be mixing a group that's coming in at 1 and another group that's coming in at 9. So we're going to have a big spread around 5, but that was correct. Okay, what are the means of factor B? Let's look at B1. What does B1's mean? 1, okay. What does B2's mean? 5, okay, so we're same numbers again, okay? And we got that by now averaging these two and by averaging those two. We're collecting like terms is one of the ways of thinking about this, okay? And then hopefully it's obvious that we have a pretty strong departure from parallelism. Is that okay? Yeah? If we took a difference here, what's 1 minus 1? 0. Let's hang on to that 0. That's our first difference. We'll put that 0 in our back pocket, so to speak. What is 9 minus 1? 8, okay, so we have a 0 and we have an 8. Our first difference is 0. Our second difference is 8. We have different differences. We have significant evidence for a departure from parallelism or for an interaction. Who's cool with that? One of the things that I hope this group will be able to do through the rest of your lives as you're looking at scientific information, I hope you will become masters of interactions. This will actually separate you from a wide portion of the rest of the population, even of people who know something about research methods and statistics. This idea about interactions is very, very difficult to develop, and I think the group is doing very well on that. Okay, so I think we get the point on the 2 by 2s, and then we could go to higher levels of complexity if we needed to. Okay, why don't we try that? So somewhere in here, it was the TED-Ed question still for the other day, for yesterday. I think I had some examples of 2 by 2s. Or 2 by 3s. Can we just have somebody walk us through that? We can hear maybe an example of a 2 by 3, and we were looking for a description of a 2 by 3 in developmental psychology. Okay? Can somebody help us out with what they had? You can dial into your TED-Ed if you like. This was question 10 on that day. This was the one for yesterday. It's probably labeled something like factorial ANOVAs. So we're looking first for a plausible continuous variable that might be something of interest perhaps to a developmental psychologist. Okay, thanks, Kevin.
I did time to full development.
Time to full development, okay. Okay, so that's going to be what we're measuring on this axis, and it's going to take some people longer to get to full development than others, and time is a continuous variable. Clearly, it can be operationalized that way. You could cut it up into categories, long time, short time, but it, in principle, is a continuous thing to be informal about that. Okay, so that works really well. Can you keep going? Did you have a couple of independent variables?
So the independent variable, the first one was level 1 would be a high birth weight infant, and level 2 would be a low birth weight infant.
Okay, so it sounds to me like her first variable is birth weight, and she's putting it in two flavors, high and low. Okay. Now, weight, of course, could have been continuous. It doesn't have to be. Our predictor variables here for factorial design can be either continuous or they can be categorical, so that's fine. That was 2, low and high birth weight. Okay. And do we have one more variable?
Yeah, and then the second one is like mother's use of drugs or alcohol.
Okay.
So level 1 would be mother who smoked, and level 2 would be mother who drank alcohol, and level 3 would be mother who didn't drink.
Oh, okay. All right. So we have 3 different levels of participation in, we might call them recreational substances. Okay, right? So that's our 3, and then our birth weight is our 2, and we're trying to predict the continuous variable of time to full development. Okay, so that works really well. And we could look at factor A, we could look at factor B, we could look at the A by B interaction. By the way, these are entirely arbitrary. Usually, I like to think of factor A as on the x-axis, and factor B as our parameterized variable, but you can change those around, and that's all fine. Okay? All right. In the interest of time, why don't we keep on moving, and why don't we see now if we can go up one notch. We started out earlier this week by talking about a one-way ANOVA, which was an extension of a t-test. In a t-test, we're really looking just at one variable and 2 levels of it. In the one-way ANOVA, we're looking at one independent variable, but we can have more than 2 levels. And that's where we introduce our Sesame Street song, one of these things is not like the others. And we need post hoc tests to tell us where those differences actually are, after correcting for cumulative type 1 error. Who's okay with all of that? That sound good? Okay, so we did that much. Now we've just bumped it up a notch, and we've gone to factorial designs first in a 2x2. Then Gabby just gave us a nice developmental example of a 2x3. Okay, but still, even in that example, that was a 2-way analysis. A 2x3 design would be run by way of a 2-way factorial ANOVA, because we still have 2 independent variables. One happens to have 3 levels. Don't let that distract you. Who's okay with that? Okay? Why don't we go up one more notch, and we'll see if we can get to a 3-way analysis. Okay? So maybe I can dial in, and I think we have, well, let's see if we can get some descriptions here first. So this is question 12. If we could jump to that. We'll design a novel 3-way, and we'll keep it simple as a 2x2x2 factorial study in social psychology. Okay? And we'll see if we can get a plausible continuous dependent variable, right? Because we're going to be taking means, right? It's still an ANOVA, and because it's ANOVA, it's a comparison of means, and we can only really meaningfully compute a mean on a continuous scale, what SPSS would call a scale variable, either interval or ratio. Okay? So can somebody help us out with what their continuous variable was on question 12? This is now for social psychology, so the topic changes a little bit. Okay, thanks.
I just was like rating the confidence.
Okay. So we're rating, maybe we're seeing a picture, and we're rating how we perceive that person to be competent as a politician, as a doctor, as a musician, whatever the case might be. Okay, so we're getting perceived competence ratings, and presumably that can go on a continuous scale. Okay, so that works. And Victoria, would you help us out with some of your other predictor variables? Okay, and we usually think of gender as being binary, right? It can be conceptualized very differently, and there's greater awareness about that. But that's a commonly used one, male and female. Okay.
Race, and I just did something.
Okay, so black and white race. So we have gender, race,
and then dress, so professional, casual.
Okay, all right, very good. Okay, so we have those 3. So we have a 3-way analysis here, even though the number 3 doesn't appear in any of those variable descriptions. That is to say, we have 2 levels of gender, 2 levels of race, and 2 levels of the manner in which the person is dressed. Okay, so we have a 2x2x2. All right, who's all right with all of that? Okay, so that's now a 3-way. That confuses some students. A 2x2x2 is a 3-way, But Gabby's 2 by 3 is a three-way. I'm sorry, excuse me, it's a two-way. I'm sorry, her 2 by 3 is a two-way, right? Because she has only 2 dependent variables. Victoria's describing 3 independent variables. Right? So 2 independent variables, 3 independent variables. Okay, maybe I can dial into a few of these. I would like to see if we can go to this one, orthogonal trends. Let me go back a bit. I'm going to dial into TED-Ed if you'll bear with me, and we'll see if we can take a look at a few of the graphs that people have drawn. Okay, we'll go to TED-Ed. And I'm really curious to see how you may have grappled with issues relating to three-way interactions. Because we've done a nice job here with two-way interactions. We're going to see if we can bump it up a notch. We'll go to review work. Okay. Let's just go to Victoria just called off something here. And I'm going to go up to question number 13. And I think that's a draw too. Wow. Okay. All right. Very good. So now we have a picture drawn of what Victoria just described for us. Okay. And the question here, that's our first challenge, and I think she's got it, is we're looking for a three-way interaction. And at first glance, I think Victoria has hit a home run here. I think that's perfect. Okay. Can I impose on you, Victoria? Why is that perfect? Or why did that work for us?
So, when you look across so I'm going to bring it up online.
Oh, I'm sorry. I apologize. Okay, well, Bob. Okay.
So, for instance, when you look at gender,
I should have done that.
The men's ratings, the means are equal, but the women's are unequal.
Okay, so way up top we have the men's graph. Here at the lower area we've got the women's graph. Okay, and I think that's all working for us. Here's one of the ways I think about this. We've got a 2x2 going here. Typically what happens is in a 2x2x2 we have now a pair of 2x2 graphs. We have a 2x2 up top. We have a different 2x2 at the bottom. The 2x2 up top has a extraordinarily clear interaction. Who's okay with that? Okay, that's prototypical Psych 200 stuff, right? We would show you that on the first day of Psych 200 when we're doing interactions, okay? And we want to give you a really clear example of that. This is a really clear example of something that does not have an interaction. Are we okay with that? Okay. So now if I asked you just to look overall at that whole picture and say, is there an interaction there or not, you'd be a little bit confused because you would say, well, there's an interaction at the first level of the gender variable, men, but not at the second level of the gender variable. So what we can say there is that the 2x2 interaction, or the two-way interaction, I should say, depends on which level of this third variable you are at. If you're at the first level, you get it. If you're at the second level, you don't get it. And that is a hallmark three-way interaction. Who's following that? Okay, that's a little confusing, right? So if we had only looked at women, we'd say there's no interaction between these variables. If we had only looked at men, we'd say there's a huge interaction between those variables. If we bring them all into a three-way analysis of variance, we can say, we actually have a three-way interaction. The two-way interaction depends on gender. It's saliently there in Victoria's men, but not in her women. Yeah? How do people follow that? Is that working for us? Okay. All right. Victoria, I'm going to stay with you if that's okay, just because I'm right here. Can I dial into, and maybe I can save us some time. How do I get back there? Oh, here I am. Okay. And I'm going to go to yours. I'm going to take a chance here. And I think we tried to, and I've never done this with a group before, I think we tried to do four-way. All right. Wow. Okay. And maybe I can make that 1 or 2 notches bigger before I go off the page. All right. Wow, I think she hit another home run. One more time. Can you walk us through, Victoria? So now we're looking for a four-way interaction. Okay? We're looking for a four-way interaction. Do you think you can do it, or are you not sure you can? You drew it. We'll see if you can talk about it. Okay? Yeah.
So my PV was efficacy of the medicine
Okay.
kind of designed to increase attention, kind of my theoretical. And so there's an interaction with the medicine,
okay.
and also with the pill placebo.
Okay. So if I can take a look at this, in the pill side, if you will, the left side of this is pill-based. Okay. The right side of this is liquid-based. Who's okay with that? Beautifully organized. Thank you for that. Okay. So in the pill side, we're really not getting a three-way interaction here on the pill side. We could have in principle, right? We could have shown an interaction up top and no interaction on the bottom. But we're showing an interaction up top and an interaction on the bottom. So we're getting no three-way interaction for pills. People okay with that? Okay. Are we getting now a three-way interaction here for liquids? Hopefully people will say that yes, we are. Sorry to interrupt you, right? But here we don't have a two-way interaction. Up top we have a very salient interaction. Okay, so we're getting different interactions, top and bottom, over on this side. And we're getting comparable interactions over on this side. Okay? So you can see how complicated this gets. We've only kept it at 2 levels for any one of these variables, but once you get to a 4-way analysis, things get pretty hairy pretty quickly. Okay? But that was perfect. We're getting a significant 4-way interaction, okay, because the 3-way interaction depends on the level of the pill-liquid variable. Okay? Beautifully done. Beautifully done. And I'm so grateful to have Draw2 now. I've never used Draw2. I think it's brand new to all of us. But it's really cool to have this generated by a student. That could have taken us 25 minutes to draw all that. I don't know how long it took you. Maybe it took you all 25 minutes to draw. But just to explain that in the classroom would have taken us a long time. Okay, let's see if we have questions on this. This is a fairly abstract idea, a 4-way ANOVA, and we're looking at the 4-way interaction. And to do that, we have to drop down by 1 number, and we look now at the 3-way interactions at each level of the 4th variable. I'm calling her 4th variable the pill versus liquid distinction. No 3-way over there, huge 3-way over on this side. That gives her a significant 4-way interaction. Yeah? Sometimes when baseball batters are on deck, they put on this heavy donut and they swing the bat and it makes the bat heavier. Are people okay with that? Once you start thinking about 4-way interactions, even if you find them confusing, then when you drop down to the mere 3-way interaction, it's a lot easier. And you drop down to something like this, and it's so whether this is really, really clear or still a little bit fuzzy, you're up in very rarefied air. You're talking about 4-way interactions. Okay? Okay. Very, very good. Thank you for doing that. Thank you, Victoria, for leading us on that. Any questions on factorial designs? Okay, so we've done a lot of TED Ed on that. What I would like to do is pop back and forth a little bit on some factorial designs between SPSS and Excel. So I wonder if we can do this much. Can you join me first in Excel by popping this one open? I put up a item out in our practice sets that says between subjects ANOVAs, and one of them is listed as being factorial. And maybe I can zoom in a little bit. So we're out on the S drive again. And hopefully up top you can see it says factorial between subject exercises. And it looks something like this if you're in problem number 1. You see now all of these designations for the different levels of factor A and how they're combining with the different levels of factor B. Here we have A1, B1, A2B1, A3B1. So all levels of A at a given level of B, and so forth. And just by a show of hands, how many people have found that Excel spreadsheet? Okay, so we're all there. Okay, we could spend almost an entire period doing this handout. I think we won't do it. We'll see. If we're way ahead of the game on Wednesday, we would do this. But here's your handout for today. And this should look partly familiar. Okay, this has basic ratios for between subject 2-way ANOVAs. Do people have that? Yeah, okay. Somebody remind us, what were basic ratios good for? What do they do for us? These Y's, A's, T's, and so forth. What are they doing for us? Okay, thank you.
They help us check determine the sums of squares.
Okay, they help us determine the sums of squares. And in our F tables, right, we have the sums of squares, and then we have some kind of degrees of freedom, and we divide the SS by the DF, as we did even in the first week, and we get that special kind of a variance, which goes by a new name called the variance is also called a mean square. It's called a mean square. And mean square between over mean square within is our ratio for any kind of an F. So this should look moderately familiar. It's strangely different because now all of a sudden, instead of having y, a, and t like we had the other day, we have a couple of other basic ratios. We have a basic ratio that will help us get the sum of squares for factor b, because now factor b is on our radars because we're doing a factorial. And then we also have the a by b interaction. So we're going to need some kind of basic ratio for each of those, a basic ratio that helps us get a, b, and a by b. Who follows that conceptually? Is that working for us? Okay. This can be enormously complicated. If you'll join me by clicking on the answer key 1, I usually take my students all the way through. Okay. And we start out with those raw data. Who remembers that we then did a squared set? We did a squared, okay? And then we start mixing and matching the raw and the squared AB matrices and so forth. We come up with our basic ratios. We mix and we match those according to this, okay? In order to get our F table, and away we go. Okay, so we're not going to spend time today doing all of that, but I just wanted to see if people could follow that logic, that we now have a new basic ratio that's going to capture factor B, the A by B's, and we can combine those here to get sums of squares, and then we're off to the races computing our F statistic. Who's following that general logic? Okay, we could spend a lot of time zooming in, but I'd really rather not. Okay, what I would like to do is a couple of things. First, we're going to paste these data in a moment off to SPSS, and I've organized them over here in a way that makes sense for SPSS. We're going to have a score. That's going to be our dependent variable. We're going to try to predict our dependent variable on the basis of two predictor variables or independent variables, A and B. And so here we have any given person as being listed in, say, the first level of factor A and also the first level of factor B, or they're in the third level of B and the first level of A. We have all possible combinations there. Who's following this, and I'll zoom in, this A1, B3 notation? Does that make sense to people? Or would somebody like clarification on that? Sometimes students get confused about these kinds of things. A3, B2. How many people are okay with that? I think they follow that. Yeah? Anybody not okay with that? Okay, so that's all looking good. So then for any given person, we can say over here that this person is in the second level of factor A, but the first level of factor B, and so on down the line. And we can just plop all these right into SPSS, and we'll do that in a minute. I did want to do a few other things, though. If you'll join me in dropping down, and I'm going to zoom in a little bit here on the F table. I'll take a moment to do this. Okay. And on the F table, I'd like to do just a little bit of computation. I want to compute partial eta squared and also eta squared. Okay. Now, generally speaking, the eta squared family tells us about the proportional variance explained. Okay. There's a couple of different ways that we can do this, and we did some eta computations the other day, and we took advantage of the sums of squares. So why don't we, just for the moment, come over to here, and why don't we do something like a partial eta squared. By the way, I'm in cell K37. Give us just a little bit more room there. Okay. Can somebody remind us how we did that computation? I've done it once before, and it was in our PowerPoints. I'll give you a hint. We have to do something with the SS's. Trying to see how much of the variance in that F can be attributed to factor A. Okay, Victoria's got it.
Isn't it factor A divided by the factor of factor B?
Okay, so it's factor A's SS. Okay, that's good. If we can all do that, equals 38. Divided by, and we're going to look at a combination of what went into that. We're going to look at this guy plus this guy. Okay, so we're looking at this, factor A, as a comparison to the total SS for that particular F, which is that and that. So what fraction of the total in that comparison is going on? So that was 39 over the sum of 39 and 150 something. That's what we have here. How many people are following that? Does that sound familiar? Okay. And I'll let you hit the enter key and tell me what you get. Yell it out if you would. Okay. 0.206. So that, in that particular comparison, factor A is explaining about 20% of the variation. People okay with that? Is that working for us? Yeah? Okay. Let's do a little trick we haven't done in a while in Excel. Let's now, if we can, do that for each of these three, but we can do that fairly quickly by going back to our formula. And remember that the denominator has a C41 in it. We can freeze C41 by putting a dollar sign before it and a dollar sign after it. We'll hit enter. And that doesn't change anything, but now what we can do is we can drag that on down, and we can pick up this one and compare it to that, this one and compare it to that. Okay, so let's see if I've got my syntax right. Okay, and we'll see how many people can corroborate something like a 0.23 and some change for the next one down, and a 0.39, almost a 0.4 on the next one under that. Okay, people are doing that fairly well. So what we're saying is, if you were just looked at this comparison alone, that's how much variance you would explain. 20% the first time around, 23 or 24% for factor B, and then for our interaction, we've got about almost 40%. Okay? Okay. So what we did there was this over the combination of itself with that. There's another way of computing proportion of variance explained, and this would be full eta squared. This is called partial eta squared, and this is what SPSS gives you. And we can check to see if SPSS gets it right in just a couple of minutes. Okay? Can you join me in going over one more column, and we'll do now eta squared. Okay? So this is not partial eta. This is just flat out eta. Okay? And there's one little trick that we might do here. Instead of asking, what is this as a numerator over that combination, we can say, what is this over the whole thing, okay? Over all the variability. Not just a portion of the variability, not just a partial bit of the variability, but all of the variability. So why don't we take an interim step here and get just, I'll go even right underneath it, we'll get a complete sum of these sums of squares. So I'm now in cell C42, and I'm going to click on auto sum, and I get something like a 339.911 and change. How many people can corroborate that number? Okay. So basically that's telling us how much variability we have in our big circle overall. Some of that variability is from our error term, our denominator. Some of that variability comes from our numerator. Our numerator has three different components to it. It has a factor A component, it has a factor B component, it has an A by B component. If we add that whole circle together, we have this much in our sums of squares. Who's okay with that? Yeah? Okay. So if you'll join me now by going over to eta squared, not partial eta squared, I'm in column L, and we'll say that for factor A, the eta squared is equal to, I'll click on the SS associated with factor A, and then I'll divide that by this grand SS. I might even label that a grand SS. And I come up with a 0.11 and some change. How many people can corroborate that number? Can we please freeze that denominator value, and then we'll drag that down. So we want to compare each of these guys to the grand total. Okay? So I'm going to go back into the formula. I'll freeze where necessary by adding a dollar sign. Okay, and then I can drag that down. Okay? And I can even drag it down one more time. I can even ask what portion of the total, of the grand total, is the error term. Right? Okay. How many people can corroborate these numbers? 0.11, 0.14, 0.29, and 0.44. Are those numbers about right? Yeah? Okay. One last trick. I'm going to put my cursor right beneath the 0.44, and I'll click on auto sum one more time. Huh. And they add to 1. Is that intuitive? How many people find that intuitive? How many people are not finding that intuitive? They don't know why those things add to 1. Okay? Oh, thank you. Okay? So, sometimes a picture will say 1,000 words. Let me see if I can go to one of our pictures for probably 1029-ish. This is one of those big, fat, multicolored pies that I'm looking for. Here we go. There's some big, fat, multicolored pies. There they are. Okay? So we're trying to explain the entire sums of squares. Some fraction there is our within subject error. Okay, and that's shown here in red. Okay? Some other fraction is going to be factor A all by itself. Some other fraction is factor b all by itself, and then we have the a by b interaction. Okay? And so if we have all of those, we had some kind of fraction associated with all of those. In this particular picture, they're all about 25%. Is that working for us? Yeah? But it wouldn't have to be that way. Even though we always have 4 components, you can see you can get any particular combination of these different items. Okay? All right, so we're just summing all of those up. Is that working? Yeah. Okay, so that's why that adds up as it does. Okay, so that's the distinction between partial eta squared and eta squared. A little bit reminiscent of the distinction that we had once between so-called partial correlations and semi-partial correlations. Who remembers that conversation? There were partial correlations and semi-partial correlations. It's a little bit similar to that in the sense that we can ask about whether we're comparing just 2 variables to each other, or we're asking about the unique contribution that one variable makes to an entire pie of variability, right? The entire data set. Okay. All right. We have about 7 minutes left. Why don't we see if we can take a peek what's going on in SPSS, and we'll get a factorial ANOVA going on in SPSS. I think that's a better use of our time than drudging through all of these computations just to get to the sums of squares, using what you have in your handout. So first, let's just go back over to this side. I'll zoom out just a tad, and you can see that we're going to pick up these 3 columns. One that contains the score, a continuous variable, on our y-axis, and then we'll have some information for factor A and factor B, who's in what group, and so forth. Okay? Let's go to SPSS, if you would open that, please. We'll go to variable view first, and we'll get a relatively rudimentary factorial ANOVA going here. It's only a modest 2-way. A couple of minutes ago, Victoria was up in rarefied air talking about a 4-way analysis. Here we're back to the more humble basis of a 2-way analysis. We have factor A, we have factor B. And I think from our data sheet, I think it was a 3x3 that we had cooking here. Okay? Okay, why don't we do this? How many people have SPSS open and you're in variable view? I realize sometimes SPSS moves slowly. In variable view, can you join me by calling the first variable score? Okay, that's going to be our dependent variable, some kind of a score. Okay. And then we also have factor A and factor B. Okay. Score, factor A, factor B, those are the 3 variables that we've got. And we're going to plug every one of you, so to speak. We'll pretend you're a participant in this study. We're going to assign you to one level of factor A, some other level of factor B, and away we go. I'm going to click over here in data view just to make sure it's all looking good. And why don't we now go back over to Excel, and we'll do just a copy and paste. Okay? So you don't need to grab the word score in factor A, but starting up at that 7 and dialing down to this lower 3, and I'll slide over so people can see me. And maybe that's too big. Maybe that's about the right zoom for you. I've grabbed this big rectangle worth of information, and I'll do a Control-C in a minute to get the ring around the rosy, and we'll do a Control-V as in victory to paste it in. Can you go ahead and do that? Do a Control-C. And we're going to go back to SPSS. We're now on data view side. We'll do a Control-V as in victory. Okay? And now we have something like 45 scores pasted in. And a given score is associated with a designation in both the A variable and the B variable, and it looks like we've got a 3x3 cooking there. Okay? So if we have a 3x3, how many cells do we have? How many different combinations do we have? 3x3? 3 times 3 is 9. Okay, all right, so we have 9, right? We have lots of different combinations going on there. Okay. All right, let's see if we can now get a ANOVA going. We'll get a factorial ANOVA going. How will I begin this analysis? Analyze, okay, right? Now, a moment ago, I think it was yesterday, it might have been Shelby told us to compare means, and you can do a 1-way, but you can't do a 2-way under compare means. Okay, it's not that sophisticated. Even though we really do want to compare means, we can't use SPSS's compare means menu. Okay, so sorry about that. So what was our other option? General linear model, okay? And we're going to stay in the univariate world because this is between subjects. If any one of our variables had been administered in a within-subject manner, we would go to repeated measures. I think we'll do some of those on Wednesday just to take a peek. Why don't you join me, please, in clicking on univariate, and I'll let you click on that to bring up that menu. That's analyze general linear model, not generalized, okay? And then univariate, we're going to use that for entirely between subjects designs. And this pops up, okay? Can you tell me what to slide where? Score goes where? Dependent variable, okay. Factor A and factor B, they go to fixed, okay? And we're going to be in fixed for the rest of the semester when we're using these kinds of regs. We're going to be assuming that we have a discrete value here and a discrete value there. You could have had continuous variables, but that's a different ballgame, okay? Okay, let's do a couple of things. Why don't we take some post hoc tests on both of these factors, okay? And why don't we do a simple Chaffee and a Tukey? Okay, we could do a Dunnett also, but that's Chaffee and Tukey. Why don't we go to options? I like to select all things for options and get means on everything. You know, we're comparing means. We're doing it in ANOVA because we're comparing means. And then we also said that we would typically like to take 4 items from this. Can somebody remind us which 4 we wanted to take from the display area? The first 3 on this side, okay, right? And the first one up top, homogeneity test. And what's that test called? Starts with an L? Levine's test, okay? So we're getting pretty good at that, okay? And we'll say, okay. All right. And in our last couple of minutes, we'll just breeze through the output here. Here's our between subjects design. We have factor A, we have factor B. We have 3 levels of each of those, and we have n participants at any particular level that you would see there, okay? Then we can unpack it this way, and you can see now we're down to having 5 people in any specific pairwise combination of those. Levine's test, you tell me, do we retain or reject the equal variance assumption? Go back, here's Levine. Retain, okay, right, because our sig value, so we have roughly equal variances that we see here, and now we're getting factor A, factor B, and the A by B interaction. We have F values of 4.6, 5.6, and 5.9. You can stay right where you are. I'll flip back over here. This is what we would have computed manually in Excel. Yeah. We'll take a quick peek over here at the partial etas. They were 0.20. I'll call them 20, 23, and 39. And then over here in SPSS, we have partial etas that are 20, 23, and 39. Partial etas 20, 23, and 39. Okay, so it's nice to see that SPSS gets that right. Who's okay with all of that? Okay? All right. And we are at close enough to 919. So now we've done a factorial ANOVA in SPSS. When we come back on Wednesday in this format, we'll do a couple of other factorial ANOVAs. We'll add a within subject variable there, and then we'll take a look at the orthogonal trend. Sorry we didn't get that far today, but we have plenty of time to do that on Wednesday. I look forward to Monday, right? We're going to have our conversation about Dr. Brooks' article, talking about extinction and spontaneous recovery. That'll take us for the first half hour, and then Vanessa will have her presentation. Thanks for a great week. Look forward to seeing you Monday.
My mom's like,